Hi guys! Welcome sa Siknayan. No? In this video ay tuturuan ko kayo kung paano ba gamitin yung GeoGebra to introduce the concept of Riemann sums. Now, noong unang panahon, kung naalala nyo yung discussion natin on the ancient problems, one of the problems was how to find the area under the curve. Na, di ba yung isang problem natin ay tangent problem, tapos yung another problem natin is area problem. Yung area problem, mathematicians tried to estimate the area under a curve. No? Yan yung, that problem gave birth to integral calculus. No? Kaya kung meron tayong function, for example, f of x, simple na lang, yung pinakasimple function x squared, for example. Yan. And we want to find the area, for example, between 1 and 2. Area under the curve, between 0 and 1 na lang. Area under the curve between, i-zoom na lang natin para kita-kita nyo. Sayang naman yung space. So gusto natin malaman yung area. What's the area between, what's the area under the curve, and from 0 to 1, of course, between the curve and the x-axis. No? So, of course, you can use integral pag marunong kayo, but if you have GeoGebra, you can just type integral, and then, yan, function, the name of the function here, the name of the function is f. And then we have the start value. Since nagsimula, gusto natin from 0 to 1. So from 0 to 1. Okay, so ito yung area niya. Ito yung, this is the area that we're talking about. And this is the value, 0.33. Actually, 1/3 yan, kung marunong kayo mag-integrate. No? Mag-aaralan natin yan, huwag kayong mag-alala. Now, before natin nakuha to, for example, wala tayong software, wala tayong formula, no? Hindi natin alam mag-integrate. No? Yung mga mathematicians noong unang panahon, no, hindi pa na-invento yung integral calculus, they tried to approximate the area under the curve by drawing rectangles. No? That's one way. No? There are other ways which we will discuss in later tutorials. So, yeah. Nag-draw sila ng rectangle sa ilalim ng mga rectangle sa ilalim ng curve, for example, dito. So, draw sila dyan. And we will illustrate that here using a slider. So, slider, number lang siya. No? Pwede mo siyang baguhin. So, from 0 to 100, for example. This slider will be our number of rectangles. Mag-draw tayo ng rectangle, di ba? So, ito yung number of rectangles natin. So, ang increment niya ay 1. Kasi 1 rectangle, 2 rectangles, and so on. Okay? So, yung slider, pwede nyo siyang i-move. Okay? Next, we draw rectangles below the curve. So, we have, ang tawag dyan is lower sum. Ang command is lower sum. Yan. The name of the function f, start value is 0, and end value is 1, number of rectangles. N. Kung ano yan nandito, kung ilan yan nandito. So, yan na yun. Ito na yung 64 rectangles. So, pag minove ko yan, nag-move din siya. Kung ilan yung n ko dito, yan yung number of rectangles ko dito. Obviously, pag dinamihan natin yung rectangles, yung approximate, di ba ina-approximate niya? Hindi yung eksakto eh. May natin yung kulay. Let's have it blue. So, yung number of rectangles as we increase it, syempre, palapit yung approximate nito doon sa area under the curve, di ba? Kasi, syempre ito, malalaki yung space na hindi nasasakop ng rectangle. Pag pinalit mo ng pinalit yung rectangle ay mas marami siya nasasakop na area under a curve, which means na mas malapit yung estimate doon sa actual area. Approximation sa actual area. Now, dito 0.33 pareho, but of course, they are not equal kasi nagra-round off na lang yung software. But if you go to options, yun nakikita, but you go to options sa taas, and then you go to rounding, and then go to kung ilang decimal places yung gusto nyo. Gusto nyo 10 decimal places. So makikita nyo, hindi naman sila tama. I mean, hindi naman sila equal. Aside from lower sum, another is pwede rin yung upper sum. No? Ano pagkakaiba ng lower sum sa upper sum? Pag lower sum, walang lumalagpas dun sa dito sa curve. So yung upper left corner, nakadikit siya dun sa curve. Lahat ng rectangles, upper left corner. Pag upper sum, yung right corner, kaya lalagpas yan dito. So upper sum, ganun din, identical naman yung command, pero yung word lang niya upper sum. We have F, we have 0, saan siya nagsimula, saan siya nag-end, saka ilang rectangles yan. So I'll make this, maybe I'll make this a different color. Ano ko muna to. Okay. Maybe green. Yan. So yung upper sum naman, malagpas siya ng konti. But if you increase again, palapit din siya ng palapit dun sa pakunti rin ng pakunti yung lagpas niya. So palapit din siya ng palapit dun sa actual area. Okay, so dito nang galing yung concept ng ng Riemann sums, integral calculus. And the idea is to make n as large as possible. And in fact, pag gumamit na kayo ng concept ng limits, as n approaches infinity, the area of the approximated area approaches the actual area. So yun actually yung concept yung connection ng limit sa yung integral calculus, ng Riemann sums. Don't worry kasi pag-aaralan natin yan sa nag-aaral na tayo ng integral calculus, no? Napaka-exciting, di ba? Hindi pa kayo na-excite. Well, this post is for teachers, no? Kung gusto nyo gamitin yung GeoGebra sa pagtuturo ng calculus. I think magagamit itong tutorial na to, no? Maraming salamat. Sana nag-enjoy kayo. Mag-subscribe kayo sa channel natin, no? Click nyo na yung subscribe button. Dami pa natin pag-aaralan. Hindi lang math, no? Nakita nyo ngayon, GeoGebra, tinuruan ko kayo. And of course, yung marami pa mga ibang software. And of course, yung mga tutorial natin. From elementary to university mathematics. See you!